First, thank you everyone for coming to this webinar today. For people who don't know me yet, my name is Yueru, and I am currently working at a financial institution after my graduation from Columbia University. I have been with the FinAI for about 2 years, and today I will be presenting one of my current project, which is called FinCriticalED, which is a fact-level evaluation of the financial OCR. Before I jump into my paper, I want to quickly go through OCR and its relationship with finance. OCR stands for Optical Character Recognition, which is a technology that converts text in images or scanned documents, those unstructured or semi-structured documents, into a machine-readable and editable text. It is the foundation of many, many downstream tasks that we are familiar with, like information extraction, QA analytics, compliance, reasoning tasks. So OCR is applied everywhere, and it is equally, or if not more, important in finance. It also has a lot of applications in finance. For example, for banking and retail, it can help reduce manual data entry and speed up the processing. For example, it can help to speed up the information extraction for the pay stubs. It also have application in compliance, risk, and KYC, which stands for Know Your Customer in the anti-money laundering. It can help you to extract data from government IDs, from your own informations, so that you don't have to manually input anything for the verification process. It also has an important role in trading and asset management. It powers financial analytics, risk monitoring, regulatory reportings, and many other applications. And one of the most well-known application is to digitize the financial statement and filings. Despite its importance in finance, it has a lot of challenges in finance in terms of OCR, because the financial documents have some very special characters. First of all, it has a complex layout and tables. So financial documents are always dense in information, and it also has many different modalities such as text, tables, and charts. And with that added layer of difficulty in the layout, it requires extreme accuracies. For example, imagine in a financial document or a financial filing 10K, 10Q, the revenue is showing 10,000 millions, so the number 10,000 in the PDF. However, after OCR, it gets translated into 10,000. So the only difference on the semantic level is that the dot after the 3 zeros moved to right for one place, which makes the meaning of the number totally different. So this might be a small errors in terms of OCR accuracy, but it can cause a large financial disasters. Such small errors, we need to avoid it completely. So we are not looking for even 99% of accuracy. We are looking for 100%, which is an extreme high accuracy requirements in finance. And it also ties to regulatory and audit requirements that we need to have those highly critical fields to be absolutely correct. So with those challenges, we can conclude that the OCR accuracy that we generally defined are not the same as the financial correctness. And therefore, we dive into the literature review, and we find that there are, in general, two different types of benchmarks related to financial OCR. The first is that we have some general domain of OCR benchmarks, which contains a lot of fine-grained tasks, such as document understanding, visual reasoning. But the problem with that is they don't prioritize financial correctness or risk sensitivity, which means that they did not address the unique challenges that we have just discussed in the finance. And therefore, we dive into another aspect that we looked into the financial benchmarks. For the financial benchmarks that we have looked through, some of them they are including the OCR tests, but the same problem persist. So with those financial benchmarks, they are addressing financial problems. They are addressing the challenges in finance. However, they did not capture the high accuracy requirements for those financial critical errors. For this financially critical fields. Therefore, there are currently no existing benchmarks that simultaneously provide the following three, which are financial-centric evaluation, OCR inclusive task design, fact level correctness, and as the evaluation target. That's why we're thinking, why not just unify those three things together? And that's why we introduce FinCriticalED. FinCriticalED stands for Financial Critical Error Detection. It is a benchmark for evaluating the financial fact correctness in the OCR. It focuses on the financial document and the critical financial facts. So the key contributions are threefold. It is the first fact level evaluation benchmark for financial OCR. And also we have our manually created domain expert annotated dataset, the FinCriticalED dataset, which have dense financially critical entities that are annotated and help us with constructing this whole framework. And also, beyond the financial domain, it is a fine-grained error taxonomy that formalizes the factual correctness as the evaluation target. It helps us to formalize the process of distinguish the materially critical errors from the benign textual differences. Our task here is that given an input image, I, from a financial document, the model generates a HTML formatted output. So the input image is coming from the unstructured the financial documents such as the PDF. So we processed it so that each image contains part of the information from the financial documents. And so we want the model to generate the HTML formatted output, which is a machine readable output that preserves both the textual content and the layout structure, include tables, headers, footnote, etc. And in order to detect those financially critical errors, we have our ground truth HTML, which is also coming from the open source of the Edgar filings from the SEC platform. We annotate each ground truth with our annotations in 5 different financial fact types. I will explain those one by one in the annotation part, but here the 5 types are numerical facts, temporal facts, which stand for time, and monetary value facts, reporting entities, and financial concepts. So for each ground truth HTML, we have those 5 types of financial facts annotated. And our dataset, from the table on the right, it is the breakdown of the financial document that we found and which type of document it belongs to. So it contains some financial statement, 10K, 10Q, some other SEC required filings, Form 4, Form 8K. We have some tax and compliance forms, such as tax forms from the nonprofit organizations, and some transaction records from the security transactions, and some financial legal documents. So all of them are open source, and each of the document type contains different characteristics. So for example, the financial statement, it contains the mixture of modality, and also it contains dense tables and informations. For example, for text forms, it have cross-page tables. And for example, for the financial legal document, it have long form legal text with embedded financial tables and contract terms. So with all those real world financial documents, we construct the FinCriticalED datasets, which are focusing on the high impact financial facts, realistic OCR and reasoning challenges. And it is also diversified so that we can capture different errors from different types of documents. So for the annotation part, because for each ground truth HTML, we are annotating them with 5 different types. So here we are leveraging the Label Studio, which the UI looks like the screenshot on the right. We leverage it to do the annotation for the 5 different types. So for numerical facts, we are focusing on the numbers that are related financially in the financial documents. So the other general domain numbers, such as the phone numbers, such as the section numbers, those are not considered as numerical facts here. And for temporal facts, we are considering 2 types: the specific date and the time periods. The date, which stands for just the day, month, and year, and the time period stands for example, 1 month, 1 year, those time periods. And for monetary units, we are focusing on the currency sign, the units after the numbers, such as the thousands, millions, etc. And for reporting entities, it is referring to the company names, the the CEO's names, the managers' names. So those names that are specific for this company. And for financial concept, it means the general financial names or financial terms that are used in the financial documents, such as revenues, assets, or it can sometimes be very long because it have several restrictions before the revenue, such as the revenue after tasks, or cost for the fixed asset, or depreciation for the plants and the equipment. So it can be very long, but sometimes they are also short. And our annotation here also shows a very high inter-annotator agreement shown in the table on the left. So we have 4 annotators in total, and we have an overall flash kappa of about 88.37%. Our evaluation here is pretty straightforward. So we only have a binary flag showing whether each error is correct or not. So if it is absolutely correct, 100% correct, without any errors, we put it as 1. And if it have any errors, which even though it is small, we put it as 0. So for evaluation matrix, we have 2 types of matrix. One type is that we use the traditional OCR matrix, which are ROUGE1, ROUGE-L, and added distance. And we also create our own financial fact accuracy matrix, which is used only for those financial critical errors in our frameworks. So it is calculated as the number of correctly translated or correctly OCR'd fact divided by the total fact in that one image. And for each financial error types, we also put a financial error type specific FFA for it. And after we get all those large language model output and we also get those ground truth annotated data, we are now coming to the evaluation. So here we leverage the large language model as judge evaluation protocol because we use we use the large language models to assess the fact level correctness for the model output and also judges the extracted fact against our gold standard annotations. The advantage of this is that it is a scalable evaluation of the complex financial fact, and also it enables a pipelined or fine-grained error analysis. And also because sometimes we are not trusting the large language model judge enough because it can sometimes be biased or sometimes miss something. Therefore, we also introduce the human expert alignment. So we chose about 4% of our data here, and we do human annotations with the same instructions we put in for the large language model judges. So we use the human annotations as the gold standards, and we compare the large language model judgment against the human judgment. And one thing we really use to preserve or to make sure that the large language model as such is not biased is that we use quantifiable numbers or quantifiable metrics in the large language model judge output. So instead of those very objective output, such as the reasoning, such as the descriptions, we actually use the definitive and very or easier to verify matrix to compare. So for example, for the output on the bottom, it is a JSON output from the large language model judges. You can see most of the output are numbers. So therefore, it is easier for us to do the human alignment. So we only need to look into the samples that we chose and verify that whether those numbers aligns with the human expert annotations. So here we had some adjustment, several turns of adjustment, and finally achieves a high alignment. So a conclusion here is that large language model as judge is reliable for financial fact evaluation in such a quantifiable way when it is properly scoped and tuned. So here we evaluated several representative models in different domains or in different under different frameworks. So we evaluated OCR models, we evaluated some open source vision models, and we evaluated proprietary vision models. And here we have the same document, of course, and we have those unified evaluation pipeline of the large language model as judge. And the right table here shows the performances under the general OCR evaluation matrix and also our fact level FFA matrix. And here we have three research questions that we wanted to find out and are reflected in the tables that we just see for the results. So the first question is, how do models differ in their financial OCR performances on traditional text level matrix versus the fact level matrix? So go back to our results here. We can see for the general matrix, there is absolutely a gap between it and the factor level accuracies. So while the general domain matrix it is pretty low, the factor level accuracy is actually sometimes 20-30% higher than the traditional matrix. So here we can see that the models can actually achieve high factual accuracy even though when their textual overlap is limited under the complex financial document settings. The second research question is, how do models differ in their handling in different critical facts? So here we are comparing horizontally among the 5 financial critical facts. So on the right side, we can see that for the FFA, it actually contains the lowest financial fact accuracy. If we are comparing within each models, it achieves the lowest. So the FFA stands for the financial concept FFA, and here we can see that it is lowest because it is very likely due to the more complex and longer forms that appears in this fact type. Because for the other types like numerical, like the dates, those are generally very short, and also it sometimes just contains a fixed length. So for the date, you can only contain the month, year, and the date. But for the financial concept, it can be very short. It can be one single word like revenue, but it can be very long because it have a lot of restrictions applying to it. So here we can also conclude that the assumption that the larger the model, the better the performance is also not necessarily true. So the colored rank on the right shows like how well these models are performing under the general domain matrix or the fact level matrix. So here we can see that for the DeepSeek OCR, it's actually performing pretty good, although it only have a 6 billion parameter size. But with the GPT-4o, GPT-5, and other bigger parameter-sized large language models, they are actually not the best performing under the under the FFA matrix. So we can see that it's not the larger the model, the better the performance. And also, we actually did 2 batches of data generation or data construction. The first batches of data that we have, they're actually of easier or like less information dense format, because in the first batch, we split the 1 page of PDF into about 5 or less chunks of information and convert it into images. So that makes the image less dense. However, in our second batches of dataset, we actually are inputting the more complex and more wholesome images. So for the new batches, we convert each page of PDF into 1 image, which makes it more complex, more information dense. And with those newly added data, we are seeing that actually the ranking of the models here changes. So in our first batches of evaluation, the ranking is not like this, but now it changes and it links towards like the DeepSeek OCR and other OCR models that OCR models or other special models that contains very special structures that is designed for OCR. So that ties back to our last research questions. To what extent do the proprietary large language models outperform the open source large language models? So the observation here is that those proprietary models does not necessarily outperform those open source models. And notably for the DeepSeek OCR, it achieves the highest fact level accuracy among all the models. So here we can see that actually the structure of the models, if it is tuned towards the OCR, it is actually outperforming those models with large parameter size. So here there is implication that model structures rather than parameter size drives the critical fact accuracies. And now we comes to the model failure. After we research those output in a very detailed way, we actually found that there are some repeatedly happening errors that the large language models are outputting. So here I put a very typical one. So we are seeing some symbol number confusion. Here we can see that the upper image is showing the actual image that we input into the model, which is there are 4 columns of percentages, and the last row shows not applicable, which is a slash, and also a percentage, which is 20.01%. However, in the large language model output on the bottom image, it confuses the minus and the 20.01% as one column. So it captures it as negative 20%, 20% here. And also the column misalignment. There were 4 columns. However, in the OCR output, there are only 3 columns. And also in the image we input, there is no headers. However, in the large language models, it output a header, even though in the prompt we mentioned that you shouldn't include anything extra, just translate or just do the OCR itself. So those are the commonly observed failure patterns that shows us how the models are failing and why we have low accuracies sometimes. So with those, we can see that there are actually some gaps between the OCR we want in financial documents and the performances of the financial or just large language models in general. And despite those amazing observations, we still see that there are a lot of other gaps that exist in the financial documents or financial domains. It's not only about the error in the financial critical fields. Therefore, in next steps, we want to introduce some new tasks. For example, the cross-page financial question answering, because we see there are sometimes very long tables that are cross pages. We want to see how good the large language models are doing to extract information or do the QAs that requires informations across pages. And also we want to explore more in footnote OCR and its cross-reference linking, because the footnote is a very, very important part of financial document. So sometimes many informations are included in the footnote, but not in the main context. So we also want to make sure that the footnote is properly captured, and also it can be correctly linked back to the main text. And also we are doing the dataset expansion both horizontally and vertically. So like we just discussed, we have already done 2 batches of dataset or annotation expansion. So next we will do the continual expansion. And also we want to have more structural and formatting diversity for the financial documents that we are collecting. And finally, last but not the least, we want to add structural fidelity evaluation, because the OCR is not only about the critical fields. It is also about how good the layout is preserved and how good the large language models are recognizing the structural or layout or reasoning errors. Therefore, we want to introduce the structural fidelity evaluation, which explicitly separate recognition errors, which is coming from general OCR, the structural errors, which is coming from the structural evaluation, and the fact errors, which we are doing right now for the FinCriticalED. So just as a summary, the financial OCR evaluation, it cannot only stay on the character level. It needs to go beyond it and goes into the fact level and high accuracy level. So the existing benchmarks evaluate OCR, finance, or dense information in isolation, and therefore that's why we introduce the FinCriticalED. That is the first fact level evaluation benchmark that unifies the OCR, finance, and the dense information evaluation. And it translates the question of can the model read into can the model be trusted with facts. So this applies beyond the financial domain. It can be applied to other domains, and it is very fundamental for all the downstream tasks which are utilizing or leveraging the OCR pipelines. And also it provides a foundational progress for building more trustworthy financial AI systems, because we do need the financial documents to be pretty accurate in order to make it be trusted for the public, especially in those stock markets and those companies that are already being scrutinized through or against those audit and regulatory department. So that concludes my presentation today for the FinCriticalED. Happy to take any questions or suggestions now, and also feel free to connect me offline if you have any further questions or are interested in the collaboration. Thank you.